Okay, well, part of objective 9 is also to give the domain and range of each relabeled function. So let's, back to this function. What's the domain of this function? Well, domain, probably ought to use of the relabeled function, which is the x minus 2 squared function, is 0 to 4. Now that's the domain of the function that we get by relabeling the extended basic function. The general x minus 2 squared function has a domain from negative infinity to infinity because the complete basic function has a domain from negative infinity to infinity. So, but here's your domain. And this interval is your range. I should put a qualifier in there. I'll call that the x minus 2 squared basic function, meaning the function you get by this relabeling on the extended basic function. Now put extended ext. Okay. Now, what's the domain here? Well, domain goes from here to here. And the range goes from here, which is not the origin, up to here. You know, this is where x equals 3/4. So if we relabel the extended basic function to get the 3 times 1 over x squared extended basic function, domain is negative 2, 2. The range is 3/4, 12. And I should probably, just to be complete, label them 3/4 that, corresponding to the 1/4 that we had here that I didn't label. Okay. This function, the domain hasn't changed. And actually, if I'm going to do the extended function, I should have indicated the range here. This function, because this is the new y-axis. Of course, it's the same as the old one, so it's okay. Started to do it here. I'm going to think better of it. And I'm going to indicate the range or the domain. Down here. I'll say domain as graphed. You could have said this on these. That's the domain, and here's the range. And I'm wrong about 2.6 because it's 2 1/4. 6. Let's fix that. And fix that parenthesis in the end too. Okay, so okay, because the domain goes from 2 1/4 here to 6. So summarizing, we relabel the x-axis by adding a number to every coordinate. It changes the domain accordingly. Changes the function. In this case, we added 2 to every coordinate. Changes the function from the x squared function to the x minus 2 squared function. In general, we add h to every x value. F of x becomes f of x minus h. The new function is f of x minus h. And in the case that f of x is x squared, the basic squaring function, and I should maybe label this basic. Squaring function becomes x minus h squared, x minus 2 squared in this case. Multiply all the y values by a number, then it's the same as multiplying the function. The 1 over x squared function gets multiplied by 3 to give you 3 times 1 over x squared function. And now your values are going to match the relabeled graph. Change the y interval, keeping the length of the interval the same. Or not. If you change the y interval, it's going to change the position of the x-axis. It's going to have the effect you see here. It's going to shift the x-axis. It's going to shift the y values, and could have said a bit. F of x becomes f of x plus k. Okay, so this is actually what we've done. We've added 2 to the endpoints of the interval, the y interval, and the function became 2 to the x plus 2. So in general, for any function f of x, if you add k to all the y values, relabel by adding k to all the y values, the function becomes f of x plus k. I'll also say that we can give you the rules for transforming functions, for these basic transformations. You can remember the rules for a little while, but you understand it better if you start with relabeling. That's kind of my idea here. And since people are doing pretty well with relabeling, this is why I want to approach it and see if people can really understand these transformations and the whole picture of how you manipulate functions to fit your data. So hopefully this is going to work well.